Okay, so we got Ag plus and F minus. So if we take a look at the table, does AgF dissolve in water?
What?
Does AgF dissolve in water?
Yes.
Yes, this dissolves in water. So we're gonna write AQ in the parentheses. Okay, I'm gonna write AQ. All right, does everyone feel comfortable solving out the rest of it?
Yes.
Okay. Sol dissolves in water. Insol does not. SL sol means it slightly dissolves. We're not going to look at that too much. Yeah, half and half, just a little bit. Yeah. So I'll give you guys maybe about 2 minutes to figure out this part right here. I want you to do the same thing for NaF and AgCl. Okay, so take about 2 minutes to do that. Okay, guys, let's go over these really quickly, and then let's just make sure we got them all correct. So NaF breaks down into Na plus and F minus. Everybody got that? Okay, and you guys should have seen that it is aqueous. Yes?
Yes.
All right, the next one is Ag plus and Cl minus. And hopefully you guys saw that this one is not soluble, so it is solid. Yes. Yeah. Because you weren't here. All right. Make sense, guys?
Yes.
Everybody good with what we did? Okay, so what we're going to be doing today is we're going to be taking this one step further. It's going to be a little bit trickier now. So I just want to make sure you guys have a good understanding. Yeah.
You didn't identify the precipitation.
Oh, thank you. I didn't even answer a question. So what's the precipitate inside this equation?
In AgCl.
Yeah, AgCl is the precipitate. Basically anything that is solid, that chemical is your precipitate. Okay, so just make sure you jot that down. So if it has an S in the parentheses, that is your precipitate. Okay. And precipitate is basically just a solid that forms inside of a liquid. Okay.
Do you have hydrochloric acid here?
We do.
How is that safe with the other stuff?
Where do you know that?
Because you watch Breaking Bad. All right, let's move on. So what's going to be different about today's lesson and going forward is I've been very nice and I've been giving you the entire equation, right? But now I'm not going to be giving you guys the entire equation.
What?
I know. So let's move on to the first problem and we're just going to jump right into it. If you guys notice, I give you guys the left side of the equation and now you have to figure out what the right side of the equation is. So it's not too bad. I'm going to teach you guys how to do it. So I'm going to give you guys maybe about a minute to copy this down. And I want you guys to do the same thing. Figure out if it dissolves in water or not. Okay, so copy down this equation. Figure out if it's soluble or insoluble. You can write AQ or S. And then I'll teach you guys how to find the right side of the equation. All right. Okay, so if we take a look at the first compound, CaS, and if we look at the solubility table, what is the positive ion that comes out of it? Yeah, Ca2 plus. Okay, so you guys should have written down that it is Ca2 plus. Okay, and I recommend writing it down underneath because it'll be a little helpful as we go through the problem, okay? Okay, if we take a look at the negative one, what's the negative ion that comes out of it?
S2 negative.
Yeah, S2 minus, right here. So we're going to write S2 minus. Okay, so hopefully you guys were able to identify that this one does dissolve in water. Okay, and I'll give you guys the other ones just to make it a little bit easier. You get Cu2 plus and you get Cl minus. Okay, everybody good with that? Okay, again, all we need to do is go to the solubility table and figure out the positive and negative ions. Okay, now before we move on, I do want to give you guys a little heads up. This is a term that'll kind of help you guys figure out how to do this problem. All right, guys. So again, make sure you guys jot this down. That precipitation reactions, another term is called double replacement. And the reason I want you guys to write that down is because it'll help you remember what you have to do. So what we're going to do here to figure out the right side of the equation is we want to do a replacement, but we're going to do it 2 times, okay? So what that means is we're going to take the positive of one of them and we're going to react it with the negative of the other. Okay, so it's like a replacement. We're taking the positive of one of them and we're going to react it with the negative of the other one. So we get Ca and we're going to combine it with Cl. Now we want to make sure the positive and negative energy is balanced out, right? So if we put Ca and Cl together, do we have more positive energy or more negative energy? Yeah, we have more positive energy, right? Because +2. So that means we need some more negative energy to balance that out. How many Cl's do I need in total to balance out this? Yeah, you need 2. Okay, CaCl2. So it's going to be CaCl2. That's the first chemical that's made. Does that make sense? Take the positive of one, negative of the other, put it together, and just make sure it's balanced. All right. All right. Next thing we're going to do is we're going to find out the other one. So again, it's a double replacement, so we have to do it 2 times. So we're going to take the positive of the other one, and we're going to combine it with the negative of the other one. So we get Cu and C and S. And if you look at these two, are they balanced out when they combine?
Yeah.
Yes, it's +2 and -2. So this guy balances out. So we're ready to go. Okay, and we just need to make sure that we put the aqueous or solid. And I'll give you guys the answer to this just because it's just to make it easier. This one is aqueous. This one is a solid. Okay. But that's pretty much it. That's how you figure out what's on the other side of the equation. Okay, does that make sense? Yes.
Can you put the CUS as SCU?
You can, but if I ask you to like name it, it might get a little confusing. So I always recommend putting the positive first. But I wouldn't take off points for putting the negative down. Okay. Alrighty. Okay, so last before we finish, if you take a look at this, we have to figure out the precipitate. So what is the precipitate in this equation?
Huh?
What's
So
the precipitate?
CUS.
Yeah, CUS. This is the precipitate because that's the solid. Okay. Make sense? All right, now before we finish, there is one thing that we need to make sure of. And the thing that we have to make sure of is we need to balance the equation. Do you guys remember that term, balancing equations? Okay, we did this back in like November. Okay, so I'm going to show you guys how to do the balancing just to make sure that we're all on the same page. And then I'll have you guys try a problem and then you guys can get started on your assignment. So when we are balancing the equation, we're going to first, let me erase some things. What we want to do is we want to make sure we have the same number of each element on both sides. Okay. So this was a CUS. Okay. So what we're going to do is we're going to count the elements that are on the left side and the right side. So first we need to figure out what elements there are. So what's one of the elements that's in this equation? Yeah. Look for the capital letter. So we got Ca. What's another one?
CU.
Okay. We got Cu.
Theo.
Cl, and then lastly, S. Good. You guys remember this kind of ringing a bell? All right. So we got Ca, Cu, Cl, and S. And let me rewrite it just to make it a little bit easier. Ca, Cu, Cl, S. And what we're going to do is we're going to count how many of each we have on the left side and the right side. And we want to make sure we have the same number on the left and right. Okay. Okay, so I know it's been a while, so we'll take it slow. I'll help you guys with the counting and everything, and then we'll just move on to the next one, which will be a little bit harder. Okay, so if we take a look on the left side, how many CAs do I have on the left side? Yeah, just one, right? There's one CA. How many CUs do I have on the left side? One. How many CLs? Two. Remember, if there's a small 2 behind it, it applies to the one right in front. Yeah, I kind of tricked you out. I was like 1, 1, 2. Yeah. So we got 2. And how many S's do we have on the left side? 1. Okay, is everybody good with that?
Yes.
The counting. Okay. Now we're going to go to the right side and we're going to count them up. How many CAs are on the right side? 1. How many CUs are on the right side?
1.
How many CLs?
2.
And how many S's? Yeah,
1.
1. There's no number behind it. It's a S.
Oh.
Yeah, sorry. Yeah, the parentheses one aren't numbers. Okay, so if we take a look at this, is it balanced?
Yes.
Yes. So this equation is perfect the way it is. So I kind of gave you an easy one in the beginning just to help you guys remember how to count the elements, but I'm just gonna let you know in the next problem and the ones on your assignment, some of them will not be balanced, so we'll have to balance it out. So numbers won't be the same, but that's a little bit later. But does anyone have any questions on counting? You guys chilling? Okay, let's go on to the last problem for today, and then I'll have you guys get started on your assignment. So please don't freak out. I know there's a lot of stuff, but we're basically combining all the stuff that we learned so far together. So what I want you guys to do is I want you guys to copy this down, and I want you guys to just finish the equation. Okay, so the thing that we did, take the positive of one, negative of the other, do the double replacement, see if it dissolves in water. So do as much as you can for this. If you want to try balancing, you can go ahead, but at least copy this down and see if you could finish the right side of the equation. Okay, so take about 3 minutes to do that. Alrighty, guys. So let me take out the positive and negative ions for you just to make sure we all did it correctly. But you should have noticed that it's going to be NH4 plus and SO4 2 minus. Okay. Any questions on the ions? You guys chilling? Yes. Okay. Sure. All right. The next one is going to be Li plus right here and Cl minus. Okay, and if you guys are confused on how we got any of these ions, you guys can take a look at the solubility table. See how it's NH4 plus, SO4 2 minus, Li plus, Cl minus. Okay, so if you guys don't know, just make sure you guys go back to the solubility table, all right? Okay, so let's do the double replacement now. We're gonna take the positive of one of them, NH4 plus, and we're going to combine it with the negative of the other, which is Cl minus. Okay? So if we put these together, are they balanced out? Is the positive and negative balanced? Sure, it's NH4 plus 1 and minus 1. Yeah, it's balanced out. Yeah, sorry, maybe I should have rephrased it. The positive and negative energy balance each other out. Okay, now let's go to the next one. We got Li plus, that's the positive. And we got SO4 2 minus. So here, is the positive and negative energy balanced out? No. Which one do we need more of? We need Li. How many Li's do I need in total? 2. Okay, so we put a 2 right there. Okay, does that make sense? Hopefully you guys remember, we've been doing this for a long time now. So we got all of the, we finished the right side of the equation. So now what we need to do is we need to balance it. So we need to count up the elements on the left side and the right side. So let's do that together. Now, I'm going to show you guys a little trick because if you guys notice, NH4 is made out of N and H, right? SO4 is made out of S and O. So if we do that, like our table is going to be really big, right? But one thing you can do with polyatomics, which is pretty neat, is on your table, we can just put the polyatomics together. So we can put NH4 together. Next one is SO4. There's going to be Li and Cl. Okay, so this makes our table a little bit more manageable. That way, on your problems, you'll only have 4. That makes it a little bit easier. That way, you don't have to count all the N's, all the H's, all the S's, all the O's. You still can, but it just might be a little bit more confusing. Okay? Alrighty, so let's start counting them up. If we take a look on the left side, how many NH4s do we have? Okay, so it's kind of a tricky question because we're looking for NH4, the whole thing. So NH4 is right here. Okay, so I'm going to put a little box around it just so we can take a look at it. Now, NH4 is inside of parentheses, right? What number's on the outside of the parentheses? 2. So that means everything on the inside of the parentheses, there's 2 of. So NH4, and there's a 2. So how many NH4s do we have in total? We have 2. So it's not, we don't multiply everything. If I asked you how many N's, there'd be 2 N's. If I asked you how many H's, there'd be 8. But we're talking about NH4. And so NH4, there's 2 of them. Does that make sense? So if there's parentheses, just get the number on the outside of the parentheses. It's 2 NH4s. Okay? Okay, let's go to SO4. How many times do you see SO4 written on the left side? 1. Okay, I know it's SO4, but we're asking for the whole thing, SO4. So we're going to write SO4, there's 1. Okay, so hopefully it's making a little bit more sense. I know there's a lot of numbers and it can get a little confusing, but with practice, it'll get better. And then Li and Cl, hopefully you're able to tell there's 1 each. Okay, does that make sense so far? Okay, I'll give you guys about 30 seconds. I want you to fill in the numbers for the right side. Tell me how many of each of these ions are on the right side. Take about 30 seconds to do that. We'll double check our answers and then we'll go to the actual balancing part. This one is not balanced.
Are you talking about first part?
Okay, guys, so let's go over the count. So how many NH4s do we have on the right side? One. Yeah, we only see NH4 one time, right? There's no parentheses or anything. How many SO4s do you see on the right side? One. Yeah, it's just written one time. How many LIs do you see on the right side? Two. And how many CLs do you see on the right side? One. Okay, is everybody good with the counts? Okay. So this is how you want to count them. And again, if it's a little confusing, I'm more than happy to help you guys out while you work on your assignment. It'll just take some practice. You guys already learned this, so it'll probably come back a little faster than if you were learning something new. Okay, so the things that are not balanced are NH4 and Li. So let's start with NH4. Okay, when we balance, we always want to add to the side that has less. So which side has less NH4, left side or right side?
Left side.
Yeah, the right side. So we're going to add NH4. However, we cannot add NH4 by itself because that changes up our equation. That is a whole new thing. We have to add the whole thing. So we're going to add NH4Cl. So we have to add the whole molecule. Okay. All right. So if we do that, how many times do you see NH4 written on the right side now? Two. Okay. But what else changed? Cl changed. How many Cl's do we have on the right side now? Two. Okay. So we got to change our Cl number. Does that make sense, guys?
Yeah.
Okay. So NH4 is good to go. This one is balanced. If you look at SO4, SO4 is also balanced. What's not balanced is the Li and Cl. So which side needs more Li, left side or right side? Left. So we're going to add Li to the left side, but we have to add the whole thing. So LiCl, and look at that. That's perfect. It gets our Li to 2, our Cl to 2, and now everybody is balanced and good to go. Okay? Does that make sense, guys? All right, last thing we do is we just need to put numbers in front of the molecules. So all we need to do is figure out, see how many times we wrote that molecule's name. How many times do we write this molecule's name on our paper? Once. So we can put a 1 if you want. If you want to leave it blank, you can do that too. But we just put a 1. How many times do we write LiCl? 2 times, so we write 2. How many times do we write this chemical? 2. And this one's also 1. And so there you go. That is your balanced equation. Okay, so just do the chart, count it up, add molecules until they balance out, and then we can just put numbers in the front. And that's it. Any questions about that? Yeah, I know this is a lot of work for one problem, right? Not enough work?
Yeah, I found out it was copy.
Oh, well, I didn't know what you were referring to.
Copy.
Okay, so one last thing before we finish up. If you guys notice, we still need to put the parentheses. So I'll give you guys the answers to this one just to make it go a little easier. This one is AQ, and this one is also AQ. All right, lastly, we're going to draw the picture of the system. So this is a thing that we've been doing. We just need to put the ions in here. I'll give them to you just because you guys should be familiar. If you guys notice on the left side, the positive ion for this one is NH4+. So we're going to write NH4+. The negative ion for this one is SO4 2-. So we can write SO4 2-. This is exactly the same thing that we've been doing. This one is Li+. So we're going to write Li+. This one is Cl-, so we're going to write Cl-. Here we have NH4+, so we can write NH4+. Okay, got Cl-, so we write Cl-. And then this problem, it doesn't have any solids, so everything just breaks up, so we can write Li+, and we can write SO4 2-. Okay, and if you ever see this, you can just write that there is no precipitate. All right, and that's pretty much it. That's what you'll be doing for your assignment today. Again, I know there was a lot of stuff, especially with the balancing, it can get a little tricky. And I'm more than happy to help you guys out. But I'll give you guys the rest of the class period to work on that assignment.